Welcome to AllCBTs. Today we'll be looking at repeated topics in mathematics, the most frequent topics that you are most likely to see in your forthcoming exam. We'll be right back. Alright, welcome back. Our first topic, which we'll be looking at, will be number-based systems. Now, what are number-based systems? Number-based systems are basically used for operations in different number bases. Now, we have the base 2, the base 3, the base 4, the base 5. Alright, base 2, which is one of the most popular, is known as the binary system. And the most common number-based system which we use on daily activities, for our daily activities, is the denary, which is the base 10, or otherwise also called the decimal-based system. Alright, today we'll be looking at the operations in different number-based systems: addition, multiplication, and subtractions majorly. So starting with addition. Now, we have our rule is that we add the numbers in each column. Alright, let's say for example, in base 2, we have 1101 plus 111, okay? Plus 111, okay? So if we want to add this, we put them in our unit forms. Alright, now the first rule says add the numbers in each column. Okay, if the sum is equal or greater than the base, remember this is for base 2. So if the sum is greater than the base, then we divide the sum by the base. So that simply means, since we have 1 plus 1 equals 2, so we do 2 divided by 2. Okay, so in our long division method, we have it as 2 divided by 2. This will give us 1, remainder 0. So 2 into 1 will give us 0, remainder 1. Reading upwards, we have it as 2 gives us 2 base 2. So 2 divided by 2 gives us 10 in base 2. So here now we will write 0 and carry 1. Now 1 plus 1 still gives us 2. Alright, so we do same thing. We write down 0 and carry 1. Now 1 plus 1, 2 plus 1, 3. So we now look at 3 divided by 2 will give us 1, remainder 1, and 2 here will give us 1, remainder 1. So 3 in base 2 will give us 11. Alright, so here we write 1 and carry 1. Since we are having 11, we write down 1 and carry 1 over. So 1 plus 1 will give us 10. Okay, will give us 2, so this makes it 10. So we write down our 10 since there is no 1. So this will be our answer for 1101 plus 111 base 2. Alright. Now, example, let's look at another example in a different base. Remember that this is in base 2. Okay, another example in a different base. Here we have 2, 4, 3 base 5 and plus 1, 3, 4 base 5. 2, 4, 3 base 5 plus 1, 4, 134 base 5. Now, adding this, now since we are working in base 5, okay, 4 plus 3 gives us 7. Now, since it's greater than 5, we'll divide. We have 7 divided by 5. All right. Now, 5 into 7 will be 1, remainder 2. 5 into 1 will be 0, remainder 1. So this gives us, reading upwards, gives us 12. So here we'll write 2 and carry 1. Now, 4 plus 3 is 7, plus 1, 8. So this gives us 8 divided by 5. This will be 1, remainder 3, and 5 will be 0, remainder 1. Read upwards, we have 1, 3. Okay, so here we'll write 3. Carry 1. Okay, now 1 plus 2 is 3, plus 1, 4. It is less than 5, so we write 4 base 5. So this gives us our answer as 432 base 5. Okay, now next what we're looking at is the subtraction. Now, for subtraction, the rule says subtract column by column. If you need to borrow from the next column, the value you borrow is the value of the base. Okay, so for us to borrow from the next column, well, it will be the value of the base to which we are working on. Now, let's look at, if we have 1, 1, 1, 1, base 2, minus 1, 1, 1, base 2. All right, now, 1 minus 1 is 0. 1 minus 1, 0, 1 minus 1, 0, 1 minus 0, 1, base 2. Straightforward. Now let's look at another example. If we have 1, 0, 1, 0, 1, 1, minus 1, 0, 1. Okay? All in base 2. Now, with this, 1 minus 1 will give us 0. 1 minus 0 will give us 1. 0 minus 1 cannot. So what do? We borrow from this. Now, the one we are borrowing from this becomes 2. Why? Because we are working in base 2. Okay? So 2 minus 1 will give us 1. So our answer would be 110 base 2. Okay, now let's look at the example we have here. We have, for another base, we have 165 base 8. Subtract 165 base 8 from 421 base 8. Okay, in doing that, we have, let's say, subtract. This will be 421 base 8 minus 165 base 8. Now, from here, we can clearly see that 1 cannot subtract, 5 cannot be subtracted from 1. So we need to borrow. So we borrow from 2. So borrowing from 2 makes 2 remain 1. We add the 1 here. Now, the one we are adding here isn't 1, it's going to be what? 8, since we are working in base 8. So 8 plus 1 will give us 9. So this becomes 9. Now, 9 minus 5 would give us 4. Alright? Now, for the second column, middle column, we have 1 minus 6, which is impossible. So we now borrow from 4, making 4 to remain 3, plus the one we borrowed, which is 8. 8 plus 1 makes it 9. Now, 9 minus 6 gives us 3. Okay, now 3 minus 1 gives us 2, base 8. Alright. So our answer will be 2, 3, 4, base 8. Next, we'll be looking at is the multiplication. Now, the multiplication, this follows same pattern as base 10 multiplication, but conversions happen at each step. Okay, example, we have 1101 times 1, all in base 2. Now, 1 times 1 is 1, 1 times 0, 0, 1 times 1, 1, 1 times 1, 1. And the next one we have 1 times 1, 1, 1 times 0, 0, 1 times 1, 1, 1 times 1, 1. Okay, at those points we do what? We add. Alright, remember we are working in what? Base 2. 1 plus 0, there's an imaginary 0 here. So 1 plus 0 gives us 1. 0 plus 1 gives us 1. 1 plus 0 gives us 1. 1 plus 1, remember 1 plus 1 is 2, but when we convert, it becomes 10. So if we have 2, alright, this becomes 1 remainder 0, 2, 0 remainder 1. Reading upwards will give us 10. So this will be, we write down 0, carry 1. Now 1 plus 1 is another 2. When converted, gives us 10. So we write down 0 and 1. So this multiply 1101 base 2 times 11 base 2 gives us our value. Okay, next we'll be looking at converting from one base to another base. Alright, so far we've looked at the addition, subtraction, and multiplication of base systems. Now, we'll be looking at converting from one base to another base. Now, first is converting non-decimal bases to base 10. Okay? Converting non-decimal bases to base 10. So we have an example here. We have 1, 2, 4.5. 124.5 base 6 to base 10. Now, if you are converting to base 10, we'll first of all label this as 0, 1, 2. Now, since we have a decimal point, this becomes minus 1. Okay? So, our first unit is 0. The tens is 1, the 100 is 2, and so on and so forth. But after our decimal point, the first we're having will be a negative, minus 1. Remember, this is expansion method, converting to base 10. Alright, from base 6 to base 10, or from any other base to base 10, we use the expansion method. And while converting from any base to base 10, we use the division method. Alright, from base 10 to any other base, we use the division method. So for this, we have this as 1 times 6 raised to the power 2 plus 2 times 6 raised to the power 1 plus 4 times 4 times 6 raised to power 0 plus 5 times 6 raised to power minus 1. Alright, now 6 raised to power 2 is 6 times 6. Now 6 times 6 is 36 times 1 gives us 36 plus 6 raised to power 1 is 6 times 2 will give us 12 plus any number raised to the power of 0 is 1. So 6 raised to power 0 is 1 plus times 4 will give us 4. Alright, now plus, now since we have a negative index up here, so this becomes 5 all over 6 raised to power 1. Okay, and 6 raised to power 1 is 6. So we have it as 5 all over 6. Alright, now adding all this up, we have this as 36 plus 12, 48, plus 4, 40, 52. That will give us 52 plus 5 over 6. So we have it as 52 plus 5 over 6. Now, since this is addition, alright, our LCM will be 6. So now this we are having as 52 times 6. Okay, 52 times 6, 52 times 6 will give us 2, 12, further 2 carry 1, 30 plus 1, 31, 3, 1, 2 plus 5. That gives us 3, 1, 7. 317 all over 6. So when converted, at the end of the day, we'll be having 52 whole number 5 over 6 as our answer. Alright. Next, we'll be looking at converting base 10 to other bases. Okay? Now, like I said earlier on, in converting from one base to base 10, we use our expansion method. While if you are converting from another base to base 10, we use our division method. But in this case, we are going to look at both our proper numbers and numbers with decimals on how to convert to base 10 from other bases. Now, for fractions like decimals, we have the whole number part and the fractional part. Now, for the whole number part, we use the repeated division method, and for the fractional part, we use the repeated multiplication method. Then multiply the decimal part by the new base, and the integer part of the whole number is the next digit. Now, this process is repeated with the new decimal part. Now, let's look at an example. We have 45. Convert 45.25 base 10 to base 8. Now, we are converting 45.25 base 10 to base 8. Now, this aspect is our whole number aspect, and this is the fractional part. Okay, so for the whole number aspect, we are going to use our division method. All right, so for 45 converting to base 8, we have this.
Run quick tests and analysis. Visit analysis.africa.
So 8 divided by 45 divided by 8. Okay, now 8 into 45 will give us 5. 8 times 5, 40, remainder 5. So 8 into 5 would give us 0, remainder 5. Now reading upwards, we have it as 5, 5. Okay, now this is base 8. Now for the fractional part, which we have as 0.25, okay, now we are going to use the repeated multiplication style or method. Now this will be times 8. Since we are we are converting to base 8. 5 times 8 will give us 40. Write down 0, carry 4. Now 8 times 2 is 16, plus 4 is 20. So we write down 0 and put our 2. Okay, now since this decimal part is now 0, no need to multiply by 8 again. All right, so our answer here for 0.25 base 10 would give us 0.2 base 8. Okay, so having that, we will now bring this fractional part and this whole number aspect together. So this gives us 55.0 plus 0.2, all in base 8. Add them up, this gives us 5.2 base 8. Alright, so with this, we've converted our 5.25 to base 8. Next, we'll be looking at converting between two non-decimal bases. Now, example is converting from base 4 to base 7. All right. Now, for converting between two non-decimal bases is simply you convert both numbers. First, convert both numbers back to base 10, and before you convert to the next base. All right. So you convert the first. Let's say we have 132 base 4. Convert to base 7. Now, if we have 132 base 4 converting to base 7, all right, what we are going to do, we will first of all convert this to base 10. After converting to base 10, we will now convert to base 7. So let's convert this to base 10. This gives us 0, 1, 2. Okay, so this we have as 1 times 4 raised to power 2 plus 3 times 4 raised to power 1 plus 2 times 4 raised to power 0. Now, 4 raised to power 2 is 4 times 4, which gives us 16. 16 times 1 is 16 plus 4 times 3, 12 plus anything raised to power 0 is 1. So 1 times 2 gives us 2. Okay, so 2 plus 12 is 14. 14 plus 16 is 30. So this gives us 30 base 10. Now we'll convert 30 to base 7 using a long division. So this gives us 30 and 7. Now 7 into 30 will give us 4, remainder 2. 7 times 4 is 28. So that will be 4, remainder 2. Now 7 here will be 0, remainder 4. So reading upwards, we have it as 4, 2, base 7. So that means we have 132 base 4 is same thing as 4, 2, base 7. Okay, now let's look at the example we have here. It says convert 2 213 base 4 to base 7. Alright, we have 213 base 4 to base 7. Okay, now first we convert this to base 10, then we convert back to base 7. Alright, now this will be 2 times 4 raised to power 2 plus 1 times 4 raised to power 1 plus 3 times 4 raised to power 0. Alright, now 4 raised to power 2 is 16. 16 times 2 will give us 32 plus 4 raised to power 1 is 4 times 1, 4 plus 3. Any number raised to power 0 is 1. So 3 times 1 gives us 3. So from here, we have it as 32 plus 4, which is 36. 36 plus 3 would give us 39. So this we have as 39 base 10. Now, converting 39 base 10 to base 7, we use our division method. Alright. Now, 7 into this will give us 7 times 5 is 35. So that will give us 5, remainder 4. And 7 here will give us 0, remainder 5. Reading upwards gives us 5, 4 base 7. So therefore we can say 213 base 4 is equal to 5, 4 base 7. So the thing to always remember there is that when converting from one base to base 10, you use your division, you use your expansion method, and converting from base 10 to another base, you use your division method. Alright, next topic we'll be looking at is fraction, approximation, percentages, and simple interest. Alright, now imagine you buy a shirt for 1,950 that was originally 2,500. Now, are you spending more or less? Clearly, you paid less for it. So that's what we describe as a discount. Alright? Now, you could use a fraction, or a decimal or a percentage in your daily life. Today we'll be connecting all these ideas together to see how it affects our daily living, and also learn how to be precise with our numbers. Now, a simple conversion is 0.5 or half. Now, if we have half, okay, in decimals, converting this in decimals is 1 divided by, we have it as 1 divided by 2. Now, 2 cannot divide 1, so what do? We write down 0, introducing our point, and add another 0 here. Now, 2 into 10 would give us 5. 5 times 2 is 10, which gives us 0. So, half is something as 0.5. Okay, now, when we talk about this in percentages, so times 100 to convert to percentage. Now, 2 here, 1, 2 into 100, 50. So half is something as 50%. Alright, now you can see how we've converted from fractions to decimal fractions and to percentages. So that we'll be looking at more examples. Alright, now fractions and decimals. Now fractions, what are fractions? Fractions are part of a whole number. So for every fraction you see is taken from a whole number. Now fractions to decimals will divide the numerator by the denominator. Okay, just like I've shown you where we did an example on half. So let's look at converting 3 over 8. This is a fraction. This is a numerator. And this is a denominator. Okay? Now, so for us to convert this fraction to a decimal, we'll divide the numerator by the denominator. So this becomes 3 divided by 8. Okay? 8 cannot divide 3, so we write down 0 and add 0. Now, 8 into 30 will give us 3. 3 times 8 will give us, okay? Now, 24, 13 minus 24 will give us 6. 8 cannot go into 6, so we add 0. Now, 8 into 60 will give us 7. 7 times 8 gives us 56. Now, this gives us 4. 8 cannot go into 4, we add 0. Now, 8 into 40 gives us 5. So, the decimal fraction, the decimal part answer to 3.3 over 8 will be 0.375. That will be 0.375 as our answer. Now, likewise, we can also convert from decimal to fractions. Okay? We simply use the place values to divide them. So if we want to reconvert this, we have 0.375. Okay? Now we have this as this is a tenth. This is a hundredth, and these are thousandths. All right. Now, so since we have 3 digits after the decimal point, we are going to have this as 375 all over 1, 2, 3. 3 zeros. So these 3 zeros represent the 3 digits. So with this, we cannot break this down to get 3 over 8. All right, let's look at another example. All right, our next example here is convert 0.65 to a fraction. Like I said, the number of digits you have after your decimal point determines the number of zeros that will be beneath your denominator. So this becomes 65 all over 100. We have 2 digits after the decimal point. We have 2 zeros as a denominator. Okay, so now this will be breaking this down. 5 here, 1, remainder 1, 5 into 15, 3. 5 here, 2 into 120. So our fraction will be 13 over 20. Now, since we can't simplify this further, this would be our answer. But in the case you can further simplify it, then you bring it down to its lowest 10. All right, now we'll look at approximations where we will deal with significant figures and decimal places. Now, talking about decimal places, now decimal places are numbers after the decimal point. So for example, if we have 5.876, remember that numbers after your decimal point are not whole numbers. So if we have 5.876, this is the first decimal place, second decimal place, and third decimal place. All right. So you need to know the decimal places and how to calculate them. Now we have round off to, we have 114.8257 and we are to round up to one decimal place, that means there should just be one decimal number after your decimal point. If we talk about two decimal places, two decimal numbers after your decimal point. Three decimal places, three decimal numbers after the decimal point. And four decimal places will be four numbers after your decimal point. But most importantly, we should also remember that 0 to 4, we are rounding it down to 0. Then 5 to 9, we round it up to 1 and add to the next number. Now, since we are asked to round this up, round up to one decimal place, now the next number, this is our first decimal place. The next number to it, the number in the second decimal place, 2, is not up to 5. Alright? So this becomes 0, 0, 0. So our answer for one decimal place would be 14.8. Why? Because the next number to it is not up to 5. Alright? But if we are asked to round up to two decimal places, alright, this will become 14.83. Why? Because our next number to 2, which is in the third decimal place, is 5. And it is up to 5, so we round it up to 1 and add to our second decimal place, which is 2. 2 plus 1 would give us 3. Now, if we are asked to round up to 3 decimal places, this would be 14.826. Same reason, the number, the fourth decimal place is up to 5. Alright, so we round it up to 1 and add to the next number. 5 plus 1 would give us 6. Okay, now, always remember that your decimal places only works for the figures after your decimal point. Decimal places only works for the figures after the decimal point. Alright, now let's look at that of significant numbers. Okay, for significant numbers deals with the entire number in question. Okay, from the first non-zero digit, okay, you work with your significant number. All right, let's look at an example. It says round off 39,481 to two significant figures. Okay, now our first significant figure, this is our first significant figure, second significant figure, third significant figure, fourth and fifth significant figure. Okay, now once we are working with our significant figures, it talks about the entire number. Okay, now this, since we are asked to round up to two significant figures, our first and second significant figure. Now, the next one we are considering, 4, the third significant figure. Is it up to 5? No. So we replace all this with 0. So this becomes our two significant figure will become 39000. Okay? If you are asked to do 3 significant figures, this is our third significant figure. The next one to it is 8. It's up to 5. So we convert down and make it 1. So this becomes 39500. What if we are asked to do one significant figure? Okay, for one significant figure, our second significant figure is more than 5, so we convert to 1 and add to 3 to make it 4000. 0. Alright, important thing to note for this is that your significant figure works entirely for the whole number, starting with the first non-zero digit, while your decimal places works for only numbers after the decimal point. Okay, next we have looking at decimal numbers to significant numbers. Okay, now from here you can see that our first significant number is 7. Okay, we have 0.7058. Now the first significant number from here is 7. That's our first non-zero digit. So our first significant number is 7. Okay, then followed by 0. So this is the first significant number, second, third, and fourth. So if we're rounding up to 3 significant numbers, the fourth significant number we have here is 8 and is up to 5. So we add 1. So making this to be to 3 significant figures, this becomes 0.00706. If you are rounding to 2 significant figures, this will be 0.0071. Why? Because our 5 is up to 5, so we round it up to 1 and add to 0. But if we are rounding off to 1 significant figure, this is 0, so this becomes 0.007 as our 1 significant figure. Alright, next we'll be looking at percentage error. Now, percentage error tells us how inaccurate a measurement or estimate is compared to the correct value. And the formula for percentage error, we have percentage error will be error over actual times 100 over 1. Okay, now our error over the actual value times 100 over 1, where our error is calculated as the actual value minus the estimated value. Okay, your error is calculated as your actual value minus the estimated value. Now, example, we have a student measures a table's length as 145 centimeter, while the actual value is 150 centimeter. Now we have to calculate the percentage error. Now, for us to calculate the error, the actual is 150 centimeters. All right, and the estimated is 145. So 150 minus 145 will give us 5 centimeters. So he has an error of 5 cm. Now, for us to calculate the percentage error, applying a formula, which is error 5 centimeter all over the actual, which is 150, times 100 over 1. 0 cancels 0, 5 here 1, 5 here 3. So this leaves us with 10 all over 3. Now, when converted to decimals, will be 3.333%. Okay, so that's how to calculate your percentage error. Always remember that your error over actual times 100 over 1. While to find your error is your actual minus the estimated value. Okay, now looking at simple interest, we have the formula for simple interest as principal times time times rate times 100. Okay, divided by 100. Now, simple interest talks about a fixed percentage of the principal amount that is paid over a specific period of time, where P is your principal, R is your rate to which the percentage is paid per year, and T is the time or period to which the money is being borrowed. Alright, now it says calculate the simple interest on a loan of 50,000 which acts as our principal. So our principal P is 50,000. Then the rate is 10% per annum, and the time is 3 years. All right. Now, using our formula, simple interest equals principal times time times rate divided by 100. Okay. This gives us principal is 50,000 times our time is 3 times our rate, which is 10%, all over 100. Okay, so here we can cancel out our zeros, leaving us with 500 times 30. Okay, now this would give us 15,000. So the interest to be paid will be 15,000. All right, now amount, it's always your principal plus interest. Okay, amount is always principal plus interest. So if you have to calculate the amount, this would be 50,000 plus the interest, 15,000, which will amount to what? 65,000. So whoever is borrowing 50,000 for 3 years at 10% per annum would pay a total of 65,000 after 3 years. All right. Total amount to repay will be principal plus interest, which is 65,000. All right. Next, we'll be looking at the next topic we'll be looking at is set. Now, what is set? Set is defined as collection of distinct objects. All right. Example: your alphabets are a set, can act as a set. Your vowels can act as a set. Your consonants can act as a set. All right. Where the universal set is referred to as your mother of all sets. Okay. In this case, if you're using an alphabet as a set, right, the universal set will be the 26 letters of the alphabet. Then the subsets can be the vowels and consonants. All right. Now, set of students in a class, okay, where we have a mixture of both boys and girls. Now, generally, they are all humans, all right, but all in one class, all right. So we can decide to use the set of students in the class, the set of vowels in the English alphabet, where we have the R, A, E, O, U. All right. Now, we can even look at the sets of numbers between 1 to 10, both even or odd numbers. Now, next, we'll be looking at, there are different types of sets, okay? Types of set. When we talk about a finite set is a set that have countable elements. Yes, the elements of the set are countable. Now, when we talk about elements of set, it simply means, okay, for example, for even numbers between 1 to 10, we have 1, 2, 3, 4. Those numbers within sets are what we refer to as the elements of a set. So for even numbers between 1 to 10, it has 4 elements. Now, this is a finite set since its elements are countable. Another example are the days of the week. Now, days of the week, we generally have.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams.